Climate. I could not, with good conscience, give a scientific talk and not talk about climate. This is one of the most well-known scientific graphs in all of environmental studies. This is a carbon dioxide graph kept over the last 40 or 50 years, showing the levels of atmospheric carbon. This one happens to also include the pH of the seawater and the amount of dissolved CO2 in the seawater. Also, as a theater student, I couldn't, with good conscience, fail to point out that this graph looks exactly like a theatrical plot diagram. Am I right? Hear me out. Here's where the story starts. We have some sort of conflict. CO2. Rising action. The tension builds up, finally, to a climax. This is where things diverge. In a story, we expect there to reach the climax and come to a safe, happy resolution. A happy ending we all want. What happens if we don't listen to the news? If we continue on without changing anything, this graph, these levels of environmental changes will shoot up into oblivion. But if we change things, and if we mitigate some of these things like carbon dioxide or sea level rise or release of greenhouse gases, we might be able to curb some of these effects. This is a different graph. This is surface sea level recorded over the last 200 years or so. Looking back, we see something changes once humans start the Industrial Revolution, start dumping CO2 into the atmosphere. CO2 and sea level rise are just two aspects of climate. But let's find a way to think about what the climate is, right? If I'm going to look up, what's the weather tomorrow? How hot is it going to be? Is it going to rain? To think about climate is just thinking about things on a bigger time scale and a bigger space scale. What's the average precipitation over North America going to be over the next 100 years? What temperature increases have we seen globally over the last 100 years? This is climate. Larger scale, larger space. But of course, climate also includes all of the things that happen to interact with these features and affect these features. Carbon dioxide affects the climate. Looking at the amount of carbon dioxide in the ocean is really important for the reason of ocean acidification. We've already heard this word in Sad Salmon's obituary of the Great Barrier Reef. But what does this mean? Ocean acidification is global warming's nasty twin brother. Ocean acidification is a process that happens when carbon dioxide and water meet and starts to dissolve carbonate-based life. Now this gets a little confusing. Look, there's equations on the board. So let me come up with a little symbol or an image to let you think about what's happening. Who's ever stood in front of a campfire and the smoke gets in your eyes? What happens?
Your eyes start to water.
Your eyes start to water. What's happening here? The CO2 from the combusted material of the fire is mixing with the water in your eyes and forming carbonic acid. That's the same stuff that's in your soda drinks. Carbonic acid breaks apart into carbonate and bicarbonate ions. This is where it gets a little complicated because those ions interact with the carbonate-based life in the ocean. Oh, come on, Byron, there can't be that much carbonate-based stuff in the ocean. Well, you're wrong, Mr. Skeptical person who just spoke out. Come on, I need some hecklers. I need, give me a challenge. So the things in the ocean that are carbonate-based are actually all around. You already know coral reefs are under threat from ocean acidification. Why is that? They're carbonate-based. The ocean acidification is literally dissolving the structures and the shells that these are dissolving the structures and the shells of these organisms. This is a pteropod shell as it's subjected to ocean acidification. Pteropods are the base of the food chain for salmon and a number of other fish species that are important to local and indigenous people right off our coast. But looking at other types of pollutants is also really important. I'm going to have said Salmon help us once again to explain the process called biomagnification.
Hello, everybody! I'm back. So, Byron has me here to explain something called biomagnification. Well, if any of you notice, I have a deformed, terrible fin on this side. It's terrible. Let me explain how this happened. All of the pollutants that are released into the air and into the water are eaten by the food that I eat. If all of these pollutants are concentrated in the bodies of the food that I eat, they get concentrated in my body too. And then whatever happens to eat me gets it even worse. What types of pollutants are in the ocean, you might ask? Well, I'm glad you asked. Things like pharmaceutical drugs and other, things like antidepressants or birth control pills or, open sewers are, severe problems, and they get into my food and are biomagnified in my body. Things like heavy metals as well. Therefore, I'm terribly deformed and my whole life is ruined. No one will ever want to, my life cycle will never be completed. No one will ever want to mate with me, and no orca would ever want to eat me. No, 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 no. Simultaneously, my greatest fears and deepest aspirations are coming true.
Wow. Every salmon is the same. They all think they're so special, but really it's me that suffers from all this biomagnification. But don't worry, there are things we can do about it to save the fish and to save me too. If we make policy changes and personal decisions that change the amount of pollutants in the ocean, then levels of biomagnification will go down and we'll all be happy. Yay!
Thanks, optimistic orca. Looking at some of the ways that climate is currently changing can be informed by the ways that climate has changed throughout Earth's history. A study of climate throughout deep time is called Paleoclimatology. Fun big words. I'm going to teach you a little bit about paleoclimatology because, unfortunately, we live in a country where a significant portion of our government doesn't believe that climate change is real. So, I'm going to teach you a few things about how to respond and how to combat some of the arguments you might hear as to why A, climate change either doesn't exist or isn't significant, or B, why it's not caused by humans. And surprisingly, you might actually come up against people who have some scientific facts behind them. But you have more science on your side, don't worry. So, we're going to talk about a thing you might hear people say, oh, it's just a natural cycle of the planet. The Earth has been significantly warmer and significantly colder throughout its history. What about the Ice Age, huh? And they're right. Except for the pace that these changes are happening. Yes, looking back through Earth's history, through all of Earth's history, this is measured in hundreds of millions of years ago, and zooming in towards the present, we see 50 million years, millions of years, hundreds of thousands, 15, or units of 5,000. Zooming in, we see that Earth has been significantly warmer and significantly colder throughout much of its history. For the last 12,000 years, we've been relatively stable. But before that, we had ice ages, and warm periods, and ice ages, and warm periods. And so it has been throughout lots of Earth's history. Yes, the climate has changed in the past. Yes, the climate will change in the future. But we're talking about the pace at which these things change and how that affects the animals and the plants and us. We are animals, after all. So the problem of climate change as we're experiencing it now is, again, not the magnitude, but the pace at which it's all happening. We've released hundreds of millions of tons of sequestered carbon in the form of coal or oil back into the atmosphere, and the Earth is trying to figure out what to do with it all. And the Earth is responding as best as it can. And the Earth is actually really good at absorbing this stuff and mitigating back to a level stasis. But if we continue to pollute, if we continue to throw temperature changes and climate changes like CO2, the ocean just won't be able to respond. Actually, I take that back. The ocean will respond. The Earth will respond. You hear people say, save the Earth, save the ocean. And while that's great and catchy, what we really should be saying is save ourselves. Look at this. The oceans survived for hundreds of millions of years. The Earth has survived. We're not talking save the oceans. We're not talking save the Earth. We're talking save ourselves. We're talking about our children. We're talking about our grandchildren and their ability to have any ocean-based food in the future, but beyond that, to have even a livable environment in terms of atmospheric pollution or in terms of climate variations, right? It sounds so much more catchy to say save the oceans, but it's a whole lot more motivating when we are the ones who are directly under threat, not this theoretical ocean thing. So again, just different ways of understanding some of the facts of the world around us. And with that, we only have one topic left. Before we move there, let's take a recap and look at some of the ways that these things have interacted. We just talked about climate. This one's easy to see how it affects things, right? It's easy to see how it's affected by things. The climate is responsible or is intrinsically tied with a number of hazards that we experience. These hazards are related to, in some ways, plate tectonics. Indigenous people understood these forces like plate tectonics. They also depended upon currents. Most of these interactions happen along the coasts. Again, it's all connected.